So hello everyone, this is the fourth problem in our array algorithm series. This is not an easy one, this is a medium one that says that we will get an array, for example here 1, 2, 3, 4, and we're going to return the another array that represents the product of every element except that particular element. So this can be done in n numbers. There is two ways to do that. Like within iteration itself, we will be calculating for every product of the every element. Element for that item, and that will take us OFN square. But if we're using also a memory and keep track of values, then also it's OFN, but it will be like, again, it will be messy. So I would like to tackle it in a easier way. For example, I first want to derive the things that I need before going for iteration. The things that we need here is the edge cases, right? First we have to pay attention to edge cases and the product. Okay, let me explain this thing. Let me make this a little bit bigger. Okay, so now you should see that here the edge cases are like what if there is you know what if there are two zeros. So if there is two zeros in this particular any array, that we know that every element will become zero, so we don't have to calculate. If there is no zero, we just have to return every element zero. And then there is one zero, right? 1 0. If 1 0 happens, what happens is like in this example, you see that if 0 happens, so the product will be present only for that element, and everything else will become 0 because they will consider 0 for deriving their project, right? So that's the two edge cases. And then the product. See, if we calculate the product of all the elements, right, then while iteration, whenever we go to a particular element, we just have to get the division of total by that element, and we should be getting the required array number. So let's get the values we need. For example, we will be getting first we'll get if there is 1 0 or there are multiple zeros. Okay, let's do that. Now there's let const zeros equals to nums dot filter right. So we get like the number of elements now. Const one zero equals to if zeros dot length equals to 1. Okay, const more than 1 0 equals to zeros dot array length greater than 1. So we find out that if 1 0 or that's multiple 0. Now we're gonna get the product. equals to nums dot reduce multiplier and then element, then we're gonna return null. Remember, if it's 0, we don't have to return the multiplication. We have to skip the zeros and get the values. Okay, if el means num exists and not 0, then we don't have to return here. If 0, then multiplication equals to el, right? This is one. And then 1. Then return. This is it. So now we have to so see, this will be OFN because we are not running an array inside an array, right? We are not running a loop inside a loop, sorry. So we are doing OFN operations parallelly, means differently, right? So when the total time complexity will be calculated, like OFN plus OFN, so on, it will become OFN, right? Only it will become OFN square, and so if we are running a loop inside another loop. But here we are running loops, but in parallel, so everything will become OFN. Now we will be returning the true array, the array that we need, that is nums that we can use map. Then we're gonna do el, right? Now if more than one zeros, then we just have to return 0, right? Else, if 1 0, if el equals to 0, return what? We're gonna return the product. Else return 0 if there is 1 0 present, right? If you have to see that if there is the element is 0, we have to return the product, the whole product we can return. Else not, you just have to return 0. Else sorry, we have to make it here. Perfect. Now else return product divided by that particular number. So this should do the trick. This should calculate the solution. Okay, it started working. So now if we go to the thing, our test cases, So let's run all the this test case. Well, what is this? Anyway, one of the test case failed. This one. Let's see what it returned. NAN. Okay. You know why NAN came? NAN came because of our this product. So here we need to the reduce has a problem. Sorry, we are doing means returning. Let me do let's say return here. Should work now. No. Woohoo! See, it worked. So there is a not a number error because the product we derived was wrong. After that, everything is good. So yeah, we had an issue because we are not returning the product properly. So everything is right. This is how we're going to implement this code. So thank you.